Why tornado research matters. Tornadoes are among the harshest natural disasters that can occur anywhere on the planet. Wind speeds that are greater than 300 kilometers per hour have the potential to demolish entire towns in a matter of minutes. However, despite decades of research, tornadoes continue to be a mystery. It is extremely difficult to accurately anticipate the exact timing, location, and severity of a tornado, despite the fact that we are aware of the large-scale weather processes that are responsible for their formation. Researchers have traditionally depended on storm chasers, radar stations, and weather balloons to gather information for their studies. Nevertheless, these instruments frequently are unable to get close enough to the most hazardous component of the storm, which is the tornado itself. The field is currently being revolutionized by drones in this particular area. The limits of traditional methods. Doppler radar has been utilized by researchers for the study of tornadoes for several decades. The rotation that occurs within thunderstorms can be tracked by these radars, which provides forecasters with some notice. However, radar is typically located a great distance away from the storm, and it is unable to measure winds directly at ground level, which is where the tornado causes the most damage. There are instances when storm chasers may place devices which are referred to as turtles directly in the path of a tornado. However, this is a very risky endeavor that frequently fails. It is also possible to collect data using weather balloons. However, these balloons tend to ascend too quickly and are typically blown away from the center of the storm. The researchers required a tool that could approach the danger zone in a way that was both safe and effective, and drones provided them with that option. How drones are used in tornado research. It is now possible to fly drones, also known as unmanned aerial vehicles, right into thunderstorms and even close to tornadoes, allowing for the collection of measurements that were previously unachievable. They are fitted with sensors that allow them to measure the temperature, humidity, pressure, and wind speed at a number of different levels throughout the storm. Several drones are released in front of a tornado to monitor the dynamics of the winds near the surface, while others are flown into the parent thunderstorm to investigate the beginnings of rotation. A novel and versatile method of data collection in real time is provided by drones. This is because drones can hover and maneuver in ways that balloons and planes are unable to. Key discoveries made by drones. One of the biggest mysteries about tornadoes is how they form. Scientists know that rotating thunderstorms called supercells produce the majority of tornadoes, but only a small fraction of supercells actually generate them. Drones are helping to solve this puzzle. By flying into the inflow region, the part of the storm where warm, moist air feeds in, drones have revealed small-scale wind patterns and pressure drops that may trigger tornado formation. They have also measured sharp changes in temperature and humidity that appear in the minutes before a tornado touches down. These insights are helping researchers improve computer models and increase warning times for the public. Drone technology and custom designs. Not just any drone can fly into a tornado-producing storm. The drones used in research are specially designed to withstand high winds, rain, and turbulence. Many are fixed-wing drones with long wingspans that allow them to travel dozens of miles into storms. Others are quadcopters, built for hovering and taking vertical measurements. Some drones are expendable. They are designed to be flown directly into a tornado, transmitting data until they are destroyed. Researchers have even experimented with swarms of drones, releasing multiple units at once to map the 3D structure of a storm in real time. The Vortex projects, Vortex, which stands for Verification of the Origins of Rotation in Tornadoes Experiment, is widely considered to be one of the most well-known tornado research programs taking place in the United States. Although radar and chase teams were utilized in the initial Vortex project, which was carried out in the middle of the 1990s, more current versions, such as Vortex 2 and beyond, have begun to incorporate drones. Gaps in data are filled by drones in these programs, which supplement mobile radars and ground equipment by providing additional information. Drones, for instance, are able to measure what is happening just a few hundred meters above the ground, but radar can only indicate rotation at greater altitudes. When taken as a whole, this paints a more complete picture of the development and evolution of tornadoes. The role of AI and autonomy. Modern tornado drones often use artificial intelligence to fly semi-autonomously. This is critical because conditions inside a storm are too chaotic for humans to manually control every second of the flight. AI systems can adjust altitude, angle, and speed to keep drones stable and focused on collecting data. In some cases, drones can decide in real time where to fly based on sensor readings, essentially chasing the most important parts of the storm on their own. This combination of AI and robotics is pushing tornado research into a new era where machines can go places too dangerous for humans. Benefits for forecasting and warnings. The ultimate objective of research conducted using drones to study tornadoes is to save lives. The average amount of time that a tornado warning is issued in the United States is between 13 and 15 minutes. That's not a lot of time for families to find a place to take refuge. Drones are assisting scientists in the creation of improved models that can anticipate the emergence of tornadoes by collecting high-resolution data regarding storm inflow, pressure patterns, and winds as they approach the ground. Because of this, the warning times might be extended to 30 minutes or perhaps longer in the future. If a violent EF4 or EF5 tornado is approaching, even a few additional minutes can be the difference between life and death. The obstacles and dangers involved in drone research. The use of drones in tornado research is not a simple task, despite the promise that they hold. Drones have the potential to be blown out of the sky by strong winds and heavy rain. The battery life is restricted, which makes it impossible to fly for extended periods of time. Flights of drones that are beyond the optical line of sight are prohibited by FAA regulations, which can make storm missions more difficult to accomplish. It goes without saying that if you fly costly drones into tornadoes, you will most likely end up losing them totally. In order to overcome these challenges, researchers are attempting to improve the durability of the systems, extend the life of the batteries, and coordinate their efforts with aviation authorities. The payout, on the other hand, has the potential to redefine how we comprehend and forecast tornadoes. In the field of tornado research, the future of drones. If we look to the future, it is possible that drones will play an even more significant role in the study of severe weather. The development of new materials could lead to the production of drones that are resistant to storms and can withstand direct hits. It is possible that swarm technology will make it possible for hundreds of small drones to concurrently map entire thunderstorms. When combined with satellites, radar, and computer modeling, drones will establish themselves as an indispensable component of a worldwide system for monitoring tornadoes. In addition to their use for research, emergency managers may potentially employ drones in the aftermath of storms to rapidly assess the extent of damage, locate survivors, and coordinate rescue efforts. In addition to their use in pure science, drones are increasingly being put to use in applications that save lives. If you enjoyed this breakdown of how drones are transforming storm science, don't forget to like, subscribe, and share. Thanks for watching, and stay safe when the skies turn dark.